Now we're recording. Hey, throw your name on here. This is first hour right now. We are starting Unit 3 today. So Unit 3 is about systems of equations. Today we are graphing systems of equations. So before we graph it, we need to know what it is. A system of equations is a collection of two or more equations. So instead of just dealing with one equation to solve, like we did in Unit 1, or one equation to graph, like we did in Unit 2, now we are looking at two or more. In Algebra 1, we're really just looking at two, but in the future you might have 3, or 4, or 5, or 6, but really only 2 or 3 is the only practical use of this. The solution to a system of equations, instead of being all of the points along one line, we're going to have two lines, and it is going to be the point that makes both of our equations true. So there's going to be one point along both lines that makes both of our equations true. In most cases, it's going to be where they cross. Alright, so for this unit, 3.1, 2, and 3, so what we're doing today and Wednesday, is all graphing. Then 4, 5, 6, and 7 are all solving, kind of like we did in Unit 1. So we're going to learn multiple ways to do the same thing. Depending on how you're given the equations, depends on which is easier, so that's why we're learning multiple ways. Your system of equation can have no solution, it can have one solution, it can have infinite solutions. Just like a single equation could have those, your systems of equations can have those as well. So if your equations have no solutions, that means they are never going to cross. So when we graph, that would be if we have two parallel lines. Most of the time, your system is going to have one solution, and that is going to happen when our two lines cross in one place. And so wherever they cross, that is going to be our solution. So like x comma y, it's an ordered pair, that's our solution. And we'll write it as an ordered pair. Okay, and then every once in a while, you will get a system where you have infinite solutions. And that's going to happen when your two lines are the exact same line on top of each other. Because if they are the same line, then every single point along those two lines is a solution to both lines. Okay, so your lines are either going to never cross, always cross, or most of the time, they will just cross one time. Okay, for today, we are graphing, and everything is already going to be in slope-intercept form for us. So we're just graphing two lines on the same graph. I told you guys in Unit 2, hey, make your lines go all the way across the graph. This is one of our reasons why. Okay, so moving down to our first example here, we've got y equals 4/3 x minus 5. So I'm going to start at -5 on my graph. And I'm going to graph a slope of 4/3. I don't want to be as exact as possible. So I'm going to go up 1, 2, 3, 4. I'm going to go to the right 3. And then if I can go again, I need to go again because I want my points to be as exact as possible. So I'm going to go up 1, 2, 3, 4 to the right 3. And then you are going to want to use a ruler, and you are going to want to take the extra 2 seconds that takes to actually line it up correctly and carefully connect your line. So there is my first line. So that's me graphing 4/3 x minus 5. Okay, my other line that I'm graphing is y equals negative x plus 2. My y-intercept is 2. What is my slope in front of this negative x? 1. So it's negative 1 over 1. You need to squeeze that in, squeeze that in. So I'm going to go down 1, right 1. Okay, see right there they cross, and I'm going to keep going. At least a couple more. So I started at positive 2, and then I did a slope of negative 1 over 1. So negative 1, down 1, right 1. Okay. Now I'm going to connect those. I did not go up and to the left because I already know where they're going to connect. Okay. And then our solution is going to be the one point where these connect. So these connect at the point 3, negative 1. So we write it as an ordered pair. Remember that x always comes first in an ordered pair. So 3, negative 1 is my solution. Excuse me. Okay. Any questions at this point? Okay, so most of the time this is what's going to happen. You're going to cross in one spot. The one spot you cross is going to be your solution. So if you knew how to do 2.4 and 5, you just got to do 2 slope-intercept form lines at the same time. All right, next one. What do you notice about these two equations? They have the same slope. So since they have the same slope, what type of line are they going to be? What? Parallel, yes. So we'll start this first one at positive 4. And then our slope is 3. So we'll go up 3, right 1. Up 3, right 1. We can also go down 3, left 1 a couple times. Actually, like 3 times. Connect all of those. Okay, other line, we're going to start at negative 2. Also do a slope of 3, so up 3, right 1. And we will see that these two lines are never going to cross. So we still need to graph both of them. Because you are being asked to solve by graphing. So you have to do a graph. But once you get them graphed, you can say, hey, these two lines never cross, so therefore there is no solution. Okay. Any questions about either of those examples? Okay, flip this over then. We've got 2 more on back, on the back. Okay, this one we've got y equals 1/2 x minus 2. So I'm going to start at negative 2. And I'm going to graph a slope of 1/2. So up 1, right 2, 1, right 2, up 1, right 2. Because I do not yet know where my 2 lines will cross, I want to go the other way as well. So I'm going to go down 1, left 2, down 1, left 2, down 1, left 2. So with my first line, I go as far as I can in both directions. Okay. Any questions on that? Okay. Once again, I have an imaginary slope of 1 over 1 here. So y equals x plus 1. I need to start at a y-intercept of 1, and then my slope is also 1. So when I start doing this slope, I'm going to go up 1, right 1, up 1, right 1, 1, right 1. So I go as far as I can up and to the right. So take a second to do that. Okay. Are those lines going to cross? So have they currently crossed? What do I need to do? I need to keep going this way. So I need to go down and to the left. So it's tempting when you see this and two lines haven't crossed to just be like, oh, well, they're parallel. Do these two lines have the same slope? No. So they're not going to be parallel if they don't have the same slope. So if they don't have the same slope, they're going to cross somewhere. You just got to figure out where. Okay. So I'm connecting these. They cross down at that very bottom left here. So these two lines cross at -6, -5. That's why being so exact and perfect, because see how like little of a cross that is? Not little of a cross, but how slanty they are together. You can't just use a really dull pencil and like not use a ruler and shade all over it, because you're not going to be able to see that one tiny little point where they cross. Since those lines are similar-ish slope. They both have a positive slope. Hey, any questions there? Hey, last one. We've got y equals -2x plus 4. And we've got y equals -2x plus 4. What do we notice about those two equations? They're the same. Not only do they have the same slope, but they have the same y-intercept. So they're going to be the exact same. This is going to be our one with infinite solutions. So we do still want to graph it. So we're going to start at 4. And then we've got a slope of -2. So I'm going to go down 2, right 1, down 2, right 1, so on and so forth. We did not put one of these ones on your assignment because, like, you can tell from before you even graph it with your eyeballs that it's going to be the same because it's the same equation. But I'm going to go ahead and put double arrows on this one so I know, like, hey, I'm graphing it twice. And then we can go ahead and write that this has infinite solutions. It's the same one. So you got to pay attention. Same slope is going to be, same slope, different y-intercept is going to be parallel. Because you'll start in two different spots and do the same slope. Same slope, same y-intercept is going to be the exact same line. Okay, any questions right now? Okay, we've got 20 minutes. I believe there are 8 problems on your assignment. I'm going to go ahead and stop this delightful... I forgot to put glue down, didn't I? Sorry about that, y'all. Let me stop this video. So grab glue if you don't have it. Sorry about that. Yeah, you're good.